All right, so what we're going to be working on here, guys, is the Google Doc that says your name and then it says U1 Properties of Compounds Lab. Okay, you can have that one open because you're going to want to make some notes, add some things in as we go, because I'm going to give you some tips and hints for the different parts of the lab. Really going to kind of walk you through this one and hold your hand, okay, through the first lab report, and then after that you're going to be a bit more on your own, okay, for this. Okay. The other stuff that's in there, this PDF is the file I'm working off of. It's basically the lab sheet that has everything on it. Just you have to, there's the parts you have to fill in, okay, for your version of it. So if you click on that, okay, basically what you get is a template. I've already filled in all the other stuff to save you time, okay? What you have to fill in, problem, so restate it in your own words, okay, in the form of a question. Manipulated variable, this is where you'll identify and explain. Responding, identify and explain, okay? You're reminded here to explain your choices. Your hypothesis, remember it's got to have if, and then. That's where you'll type it. The materials, you don't have to do anything with that. I've just put them there so that they're there, okay? But it also contains the possible identities of all the unknown compounds. Okay, so one of the compounds is ammonium nitrate, one of them is paraffin, which is candle wax. Okay, one's hydrogen chloride, and et cetera, et cetera. Okay, the procedure, you're going to type that up. We'll have class time tomorrow to do that, so you'll be typing in there. Okay, then there's your observations chart. So I've built that for you. All you have to do is type into it, but obviously on Monday, you're not taking a Chromebook over to the lab. Right? So you'll need to have that chart maybe blown up and printed so that you can write in it and then transfer it over after the fact. Okay? Unless, of course, you want to fill it in from your phone. People do that as well. Okay, so you want to fill in that chart from your phone in the lab. I'm okay with that, whichever way works. Okay, and then for there's the analysis here. Okay, and then you've got your sample codes. So you say sample A was an ionic compound and it was hydrogen chloride or whatever you decide it is. Okay, and so on and so on. Okay, you fill that in. Then you got your conclusion. Fill in your conclusion. So copy and paste your hypothesis. Fill in your conclusion. Evaluation. Identify your sources of error and suggest improvements. And you're good. You don't have to do the class discussion stuff. That's stuff that we'll talk about after I hand back all the lab reports. Okay, and then this is just what each part is out of. But on Google Classroom, there's actually rubrics that I use, and I just fill in your grade in those rubrics, so you can always go back and check where you got your marks, where you lost your marks, and why. Okay. All right. So questions on what we're doing. All right. So you guys will be working out of that document and just adding to it as we go. Okay. So the problem I have written here is, given several unknown samples, how can we classify them as ionic, molecular, acids, and bases in order to find their identity? Okay, so you've got to write that in your own words in the form of a question. And think about what we're trying to do in this lab, right? We're trying to use the physical properties of substances to find their identities. Find some way to put that in your own words in the form of a question, okay? Mentioning physical properties and finding identities is probably a couple of things you'd want to have in your question. Okay, if we're thinking about how the lab is going to go, okay, so the lab's going to work like this. You'll have your unknown samples at the front, okay? Each one of those unknown samples is going to be tested in the same way, okay? We talked about those tests yesterday. We're going to do an observable properties test. We're going to do a solubility test. We're going to do a conductivity test and a pH test. Every single sample will have the same tests run on it, okay? And each sample is going to respond to those tests differently, okay? But each time I run those tests, I'm testing a different material. So I could maybe say that I'm manipulating what sample I might be testing. Okay? Since each time I run the experiment, it's essentially on a different material. Okay? And what material I test affects what results I get. So remember, when you're explaining your variables, okay, you want to explain how you're manipulating. Okay, so we've kind of given it away, but your manipulated variable is the samples. Yeah, okay, I'm giving it away, you're welcome. Okay, tell me how you're manipulating it. Okay, and why. Okay, your responding variable, okay, what's going to happen? Every time I test a different material, I'm going to get different something. Okay, talk about why. Okay. Probably not a bad place to mention something about physical properties. And it would be in that explanation. Okay. If we're talking about our controlled variables, we're talking about what things we want to have the same so that our test results are fair. Okay? So what things do I want to keep the same, do the same, okay, each time I test a new material? I would say your easiest controlled variable would be that each time you test a new material, you're testing it the same way. Okay? It would hardly be a fair experiment if for one sample you did an observable properties test and a pH test, and for the other one you did a solubility test and a conductivity test. Okay? You're not getting a full data set for each one of them. It's not a fair comparison. It's not a controlled experiment. Okay? So there's one. You have to repeat. Okay? Controlled variables can be procedural, like that one was, and they can be environmental. Okay? Some of our tests could be affected by the environmental conditions in the lab, especially the solubility test. Okay? Something about the lab could affect the solubility test. Okay? Something about how we run the conductivity test needs to be the same. Okay? Possibly what we might use in it. Okay? So those are things to think about without like totally giving them away, but sort of giving them away. All right, so for our hypothesis, remember that we want to have an if and then statement. Okay? Now, the whole premise of this experiment is that we can identify these compounds. And we can identify them because they have different what? Two words, they both start with P. Physical properties. Okay? That's the premise we're working on, that all materials have different physical properties. If that's the premise I'm working on, should I talk about that in the if part of my hypothesis? Because if that's true, and I run this experiment, then I should be able to identify all the materials based on their physical properties. Okay? So in our if part, we should probably talk about how we believe all materials have their own unique physical properties. Now, caution here. Words that we don't want to have appear in our hypothesis. I, we, us, you. Okay? Because our hypothesis needs to be generalized. Okay? So we don't want to refer to specific people, especially ourselves, in our hypothesis. Otherwise, when it comes time for someone to repeat our experiments and verify our findings, we have to be there because we're in the hypothesis. Okay? So our if part needs to talk about physical properties. If all materials have unique physical properties, whatever, however you want to say it, okay? And describe the experiment without saying, I'm going to do this, we're going to do this, okay? Or you should do this, okay? Just talk about the experiment, okay? Maybe just, talk about some tests being run, or maybe you're going to name the test. There's only 5, okay? 4, there's only 4, okay? So you can talk about them, just these are the tests that will be run. Then okay, talk about what's going to be possible. Then it will be possible to do this, rather than then I will be able to do this. Then it will be possible. Then you're not part of it. Okay? It's weird, it's picky, but it's important. All right, give you a couple minutes to kind of play around with your hypothesis, get some ideas in there. So the if part, okay, we want to talk about physical properties, okay, unique physical properties, okay, the and part, okay, we want to talk about, you know, observable properties, solubility, okay, aqueous conductivity, and pH, okay. In the then part, okay, we want to talk about it will be possible to ... All right, the next part's the part that's probably going to take you the longest, okay? And that's, you kind of write out the procedure, okay? We already know what tests we're going to run, okay? But what we need to talk about is, when we get into the lab, what are the things we're going to do? Then what tests are we going to run? How are we going to run them? And what data do we need to record? If you recall, in that document you had earlier today, when we're talking about lab report expectations and format, it said the procedure is an explicit set of instructions, okay? And by explicit, I don't mean it's full of F-bombs and four-letter words, okay? I mean that it is very, very descriptive. It leaves no room for error or your own kind of interpretation. Do this and do it this way, and then do this and do it this way, then record this, okay? You have to be very, very explicit, okay? Leave nothing to doubt. If someone's like, okay, well, what does that mean? How do I do that? Then you haven't done a good enough job on your procedure, okay? It's got to be like a cookbook, okay? First you put in the eggs, and then you put in the flour and whatever. Okay, you got to have it step by step by step that they can follow. So it does then need to be a numbered list. Okay, the most common mistake I see when people write out their procedure is they make a paragraph. They might have numbers within the paragraph, but it's a paragraph. How easy is it to lose your place in a paragraph? If you're reading a book, obviously you're probably not going to lose your place in a paragraph. But if I'm doing a procedure, I'm on step 5 of step 15, and it's one paragraph. I do step 5, I turn away from the book, or the sheet, or whatever, I go do step 5. When I come back, I'm like, I was on step 5. I have to read the whole paragraph again to find where step 5 is, okay? And that's even worse if someone hasn't numbered it. They've just written a paragraph. It's like reading a story, okay? I don't have time to do that if I'm trying to do a lab, okay? It's inefficient. So it needs to be a numbered list. Step 1, go into the lab and get the safety gear. Okay? I mean, realistically, that's the first thing we should do when we walk in the door. Okay? Is go in and get safety goggles. Okay? We could even, if you wanted to, make sure your mask is on and you sanitize your hands. We don't have to do that, but okay, I mean, realistically, it's something we'll have to make sure we do. Okay? So acquire safety equipment, goggles, lab apron. Okay? Second step could be acquire lab materials from front bench, okay? Because I'm going to put all the lab materials on a cart or on the bench at the front of the lab. One person from your group will come up and get it, okay? These are all the things, and I know you're probably thinking, well, that's dumb. Would somebody figure that out if they walk into the lab? Well, what if they don't walk into this lab? What if they walk into a different lab? Okay? Stuff's not going to be necessarily in the same place, okay? So you have to be explicit. Acquire these materials. Okay? Once you kind of set them up so that they have everything, okay, they've got all the stuff that they need, then you can start talking about each test. Right? So what test are we running first? No, not solubility. Before. We're doing the observable properties test first. Okay? Now, if in your procedure you write perform observable properties test, step 2, perform solubility test, I have no idea what to do. Okay? What's an observable properties test? What are observable properties? What am I looking for? What should I write down? These are all things that you need to put in your procedure. So, perform observable properties test. Do this by recording the state of the material. Record the color of the material. Record this, record this, record this. Tell them how to perform the test. These are the observable properties you need to look for. Okay? This is what needs to be done. Okay? So it's going to need to be specific. Right? And the next test we're going to run after observable properties is going to be solubility. Okay, now we said during our solubility test we needed to make sure of a few things. What kind of water are we using? Distilled water. It's in the wash bottles. Okay, how full am I making it? In fact, when we're saying acquire the materials, probably one of the things you should tell them is how much. Okay, in that depression plate, if you don't tell them how much, maybe they fill it right to the top with the sample. How are they going to do a solubility test now? Okay, they got too much sample. We only need a little bit of sample. Okay, cover the bottom of the depression with sample. Okay, these are the kinds of specific bits of information and instructions that need to be in there. Okay, for the solubility test, I would say add water until the depression is 3/4 full or 2/3 full. Obviously, you don't want to fill it all the way up because then when you stir it, it'll spill everywhere. Okay, so these are things to consider. They're the kind of details that need to be in there. Okay, they're the things a normal smart person would take for granted. But remember, you're writing this imagining the dumbest person you know. I know that's not very nice. Okay, don't say who that is. Okay, but the dumbest person you know, okay, is trying to follow these instructions, and they just, if you don't write it down, they'll screw it up. Okay, that's who you're writing it for.
Don't have the measurements for the water and the samples and things like for everyone?
Will they be the same for everyone? Hopefully. Okay, in general. For our purposes, exact measurement of the amount of everything is not going to be crucial to the results we get, as long as we're in general about the same. That's why I'm saying cover the bottom of the depression with sample. That'll be enough for what we do, rather than having to bring out a scale and say measure 1 gram of everything. That makes this lab take twice as long. Okay, we don't need to be that accurate. Okay, if we were really worried about that, then we would. Okay, but for our purposes, that's controlled enough. You're right, though. If we were trying to really be controlled, yeah, it should be 1 gram of everything. Okay? When we say how much water to put in, fill it 2/3 of the way full. Well, water is the same for everybody, so we know we'd be putting in the same amount of water for everybody, approximately, at least within what we need. Okay? Tell them what kind of things they should be recording during the solubility test. When do you put the thermometer in? Okay? You put the thermometer in before you add the water. Okay? Should you record the temperature before and after? Okay? These are the kind of details that need to be in there. Okay? See how this procedure could get pretty long pretty fast? Okay? Because you have to be that specific. Once the solubility test has been performed, okay, you should probably be telling them what to record. Well, obviously, you're recording temperature change, recording, if the sample dissolves or not, changing color of the water, okay, all of that kind of stuff are observations that need to be recorded. Okay. Then we perform which test after that? Before we do pH, we do conductivity. Okay, because remember, we put pH paper in there, we're putting ions in. Oh, shoot, we're out of time. Okay. We'll continue this tomorrow.